Hi everyone. Today in this video we are going to derive the torque equation of a DC motor. So the meaning for the torque or the definition for the torque is turning force or twisting force is known as torque. Let us assume an example to understand the torque, right? So let us assume a bullet cart. The bullet cart is in case 1. In case 1, the bullet cart is empty. The cart is not loaded with any kind of loads or any kind of bags, loaded bags, and now the bull is asked to move. Right now, the bull will feel very comfortable to pull the cart without load, and its speed will be also higher, but its torque will be lower in case 1. Now let us have the another case. In case 2, I am going to load 100 kg of load or 100 kg of some material bag on the cart. And now I am asking the bull to pull the cart or pull the load. Now the bull will feel somewhat difficult compared to the case 1 where there is no load. It will try to catch the same speed in case 2 with respect to case 1, but it cannot achieve the same speed because in case 1 there is no load, but in case 2 there is 100 kg of load. So it will try to achieve the same speed with respect to case 1 as in case 1, but it cannot. But it will apply some energy or force to catch the same speed is known as torque, right? So here the speed will reduce and the torque will be higher. Speed will be lower and the torque will be higher. So in case 1, speed is higher and the torque is lower because there is no load, and in case 2 there is a load, 100 kg of load. Here the speed will be lower and the torque will be higher. So the torque is something known as turning force or twisting force to pull some means of load, right? So let's start the torque equation of DC motor. For that, let us assume a brake drum of motor. So this is a brake drum of motor. It has a radius R, and it is rotating in clockwise direction. The arrow mark indicates the clockwise direction, and the force due to rotation will be on the circumferential force due to this rotation will be F. This is F, indicator as F. So now, as I already told, torque is nothing but turning force or twisting force. Now this force will have Newton as the unit, right? So the wheel, let's consider this brake drum or a wheel. This wheel is rotating at speed of n rpm. Let n be of 1500 or 2000, what it may be, and its unit is revolution per minute. So the wheel is rotating in n rpm. Now the angular speed of the wheel is given by omega is equal to 2 pi n divided by 60, and its unit is radians per seconds. So this is the angular speed of the corresponding wheel or brake drum. Now the work done of the brake drum or wheel in one revolution of the wheel in one complete revolution is given by work done is equal to W is equal to force into distance traveled in one revolution. Here the distance traveled in one revolution specifies or indicates the wheel, right? So the distance of the wheel traveled in one revolution denotes this corresponding parameter. So it can be written as F work done W is equal to F into 2 pi R. 2 pi into R. So this is the R is the radius and 2 pi is the distance traveled. So both are product. So 2 into pi into R. So from this the power developed P is equal to power developed in the wheel P is equal to work done divided by time. Now it can be replaced with the help of work done. So already we know the value for work done W. So W is equal to F into pi 2 pi into R. So F into 2 pi into R. The divided by time taken to complete one complete revolution. Time taken to complete one revolution for this wheel is n RPM. So it is in minute. The unit is in minute. So the time will be 60 by n seconds. We are converting it to seconds. Now this relation can be also written as F into R into this n will become, or the n will go to the numerator. So n into 2 pi or 2 pi into n divided by 60. So this can be also written as two pi nt divided by 60 into F into R, right? Here this F into R is nothing but torque T, right? So this corresponding force into radius is the radius of the wheel, and the force acting during the wheel rotation is F. So which is nothing but torque T, right? Into this 2 pi nt divided by 60, 2 pi nt divided by 2 pi n divided by 60, 2 pi n divided by 60 is omega. Omega is angular speed, right? Omega, right? So P is equal to, therefore P is equal to power developed in the wheel is equal to torque into omega, right? So this is omega and this is torque, right? So we are expressing force into radius as torque, and 2 pi nt by 60 is equivalent to omega, angular speed, right? So this is the power developed in DC motor, right? So from this, and the unit for power is watts. Next, we'll calculate the value of torque, right? We have calculated the angular velocity, angular speed, and power. From this, we need to calculate our ultimate aim is to calculate the torque equation or torque value. So next, we'll start with the torque value. So power in armature, or power developed in the armature, is equal to armature torque into omega. So this is the relation from power equation of DC motor. This is the relation already we have from the power equation of DC motor. So power in the armature is equal to, or power developed in the armature is equal to armature torque, torque produced in the rotor or armature conductors into angular speed, right? So this can be expressed as, or the armature torque means I, TA, armature torque means TA. This is also known as gross torque, TG, right? Gross torque means overall torque produced in the DC motor. So this power in armature can be expressed as EB into IA. This is the relation from power equation, EB into IA. So which is equal to, where EB is the back EMF and IA is the armature current, which is equal to armature torque is TA, T suffix A, into the angular speed is equal to 2 pi N divided by 60. 2 pi N divided by 60. From this we already know that back EMF, since back EMF EB, E suffix B is equal to 5P NZ divided by 60A, right? So I'm going to substitute this EB in this relation. So 5P NZ divided by 60A into IA is equal to TA into 2 pi N divided by 60. Now I need to find the value of TA, so TA is equal to, because I need to find the value of torque, armature torque. So TA is equal to 1 by 2 pi, or I can write this, I'm keeping TA here right side and bringing this term this side, left side. So 5P NZ divided by 60A into IA into this corresponding term will become 60 divided by 2 pi by N, where 60 will be cancelled and the remaining I will have 1 by 2 pi into 5 into IA into this N will get cancelled. So PZ divided by A. This is armature torque. So when I simplifying this 1 by 2 pi term, I will get 0.159 5 into IA into PZ by A Newton meter. The unit of torque is Newton meter. So this is the final torque equation or torque expression of DC motor, or armature torque is equal to gross torque. So this is the total torque developed in the DC motor, or this is also known as armature torque, TA. So TA is equal to 0.159, phi is flux, IA is armature current, phi is number of poles, Z is number of armature connectors, and I is number of parallel paths. So torque depends on flux, armature conductor, number of poles, armature current, number of poles, armature conductor, and parallel paths. I think you are clear with the derivation of torque equation of DC motor. Thank you.